Now let's do part B now, which is they say if f of x is equal to x cubed minus 8x plus 10, they're now saying show that there is a value c such that f of c is equal to pi. Okay, show that there is a value c such that f of c is equal to pi. So basically, I should prove that there is a value which gives a value bigger than pi and a value smaller than pi. Then we know that there is going to be a value in between which gives us pi. You get what I mean? That's just how it is. So you have to just prove that there is going to be a value which is bigger than pi, and then there is a value which is less than pi, and then if there is a value which then if we have a value which, because it's like these things are continuous. You see, this graph is the graph of x cubed something, which is either like this or either like this. There is no break on these type of graphs. These are polynomials. There is no break on. These are all continuous things. Okay, these are all continuous graphs. So once they start, they keep going until they finish, right? So now, if we say that there's going to be a value where f of c is equal to pi, that means somewhere there is going to be a value that it's f of some value is going to be greater than pi. Then we are going to have another value where f of that value is going to be less than pi. Then we know that in between there is a value f of c which is equal to pi. That's how it works. Okay, you see, that's how it works, right? So this is what it is. We can go ahead and prove that now. So now, what you must just know is that, what is pi? Pi is going to be equal to 3 point something, you know? I'm putting 3.14, blah, blah. So we need a value which gives us an answer which is like less than 3, and then an answer which is more than, okay? So for example, I'm going to try, we're smart, we know how to do it. We can use a calculator. Let's try what is with our pencil. What is f of 1? It's going to be 1 cubed minus 8 by 1 plus 10. What does it give us? So we say 1 cubed minus 8 open bracket 1, then we say plus 10. This gives me 3. So here I'm going to get 3. What about f of 2? Well, so we can say f of 1 is less than pi. Now we want one which is greater than pi. So it's going to be now, what is 2 cubed minus 8 by 2, then plus 10. This gives 2. Okay, so f of 2 is 2 cubed minus 8 by 2 plus 10. This gives 2. So f of 2 is also less than pi. Okay, so what about f of 3 now? What about f of 3? We can say 3 cubed minus 8 by 3, then plus 10. This gives 13. So f of 3, where we say 3 cubed minus 8 by 3 plus 10, gives us 13. So we can say f of 3 is bigger than pi. So we can even use 2 and 3, or 1 and 3, whatever. In between them, we can use 2 and 3 since we just got 2 is less than pi and 3 being. So here you're going to say, now, once you have two values where one is less than, the next one is bigger than, then we know between them, there has to be a value which is going to be equal to. So you're going to say, let x be equal to 2. F of 2 will be equal to 2 cubed minus 8 by 2 plus 10. And this is going to be equal to 2. Then you can say now, let x be equal to 3. You can now say f of 3 is going to be equal to 3 cubed minus 8 by 3 plus 10, which is going to be equal to 13. Now here you can now say here, since you're now showing that f of 2 is less than pi, but pi is less than f of 3, then that means that by IVT, by the intermediate value theorem, you can say there is a value, c such that f of c is equal to pi, and this is between x equal to 2 and x equal to 3. Because, you know why? It's because one gave us a value less than pi, one gave us a value bigger than pi. So in between, there has to be one which gives us a value which is equal to pi. because we're going to cross from less than to more than, and without jumping. So that means there has to be a point where it is equal to pi, and that is what we have shown. Now we are going to go to the next one, which is part C. I know you're understanding it. The intermediate value theorem just tells us that it's just to prove. It's a proof theorem, okay? It's not to find the value. It's just to prove that there is a value there. By proving that you have an answer we have a value which gives you an answer bigger and an answer smaller than the value you're looking at. So that means there's going to be a value in between which gives us exactly the value which we want. All right, now that's it. Let's go to part C and let's see what's up.